Cooking. All right. So homework for today was to modularize our soccer game, right? Okay. And we'll go through that and do some of that in class today. And then I want to also start introducing objects from chapter 7 here. So your homework assignment for over the weekend is you might look at the warm-up exercise 6.15. These two are pretty similar to each other, but just the warm-up is kind of a starting point. But 6.16 effectively has you enter in a sentence and then do a bunch of string manipulation stuff with a menu. So similar to the soccer thing, except instead of manipulating contents of an array, you are manipulating a string. All right. So, and the approach should be a modular approach, given that it's in the chapter dealing with methods. All right. So I'll make sure I put that up, hopefully very soon after class today. So you have a Dropbox, but I would get started on that relatively early. It's not so much difficult as it is just there's lots of menu options. So you'll probably be writing 4 or 5 methods to do the different things. Okay. So let's go to kill that for battery life. And we use Eclipse in here, right? Okay. Now, how did the homework go? We feel like we're getting better, we're improving. Each time we have an assignment, it's twice the size, but takes either the same amount of time or a little bit less time. So we're getting a little bit better at it. Okay, well, that's a good sign. Okay, so for our homework, we were supposed to modularize this code with the hope of having main be kind of concise. What I like to kind of aim for is our main method, and a phrase I often say is this idea of all programs begin and end with main. So when you start your program, we start at line 1 of main, and main is our maestro that dictates where we go throughout the program. Sometimes it sends us to another function, sends us to one of our methods, and that method might send us someplace else, but ultimately we're going to make our way back to main. So main, a goal I have typically for main is for it to look like my algorithm. So as we sit down and we write our instructions, you know, our high-level instructions for how to solve a problem, here's our major things we need to do. And then within each of those major things, we have a bunch of details, right? Those details maybe get sucked into a method. Whereas when you look at main, you see those major things. Do this, then this, then this, then this. So main becomes very clear as to, in terms of what it's trying to accomplish, as opposed to like right now, we have this wall of text, and you know, even though it's not that much, it's more than most of us are used to, and therefore it looks intimidating. We're going to have the same text. The code's going to be somewhere. Okay, but if we can compartmentalize it in a little method somewhere else and then minimize them so they're not so scary, and then have main just say call this guy, then this guy, then this guy, then this guy, it's going to make our life less intimidating and more organized. Okay? So we already wrote a function last time called showMenu, and showMenu returns a char, takes no parameters, and we decided to go ahead and have this guy create his own scanner so he would have access to that. And we were kind of debating last class. We reviewed this idea of variable scope. What's variable scope again? When I say variable scope, what am I talking about? Okay, let's say no. Loops do have their own scope. A for loop has their own scope. So we'll say that you're not really close. All right, somebody give me a different answer. What do I mean by variable scope? Okay, so we have multiple scopes. So we have this idea of a global scope, and we drew this picture last time, right? What program I use? Keynote? Yeah. I found that my consciousness is on about a 3-second delay today, just like a lot of TV shows. All right. Yeah, so we drew this picture last time, right, where we have this idea of a global scope, and then this guy may contain, well, since I just mentioned that all programs begin and end with main, it'll at the very least, as far as our world's concerned right now, it'll contain a single inner scope associated with main, right? So this is kind of what it looks like, but if you had to define what it means to be a scope, what is a variable scope? Give me a single sentence. It doesn't have to be overly, I mean, most of the answers I fish for are not technical answers. Go ahead. Variable lives and dies. I think that's pretty good. You could also throw on there, where we have access to the variable. We have access to it in the environment where it lives and dies. Okay, so variables are compartmentalized inside of scopes, and they make themselves available to the rest of the scope in which they live from the point they were defined on. So maybe a quick way of saying it is, what is the scope of a variable? It is the area in which the variable is accessible. Where can we access the variable? Something like that. Okay? So we decided, we had a couple of different options we were debating last time because our scanner originally was written up here in main. We had defined the scanner somewhere up top here, and so its scope was local to main. So we had a couple of suggestions. Mr. Rohde, who skipped today, did he skip, or is he in another class this day? He's in his internship. Oh, okay. I think he has permission to skip on Thursdays. He watches the video, but we'll still make fun of him, I guess. So in any case, he suggested that we maybe move that variable into the global scope, which would just give us access to it everywhere. Not a horrible idea. That broke us into the discussion last time about how a lot of books kind of claim that global variables are bad. And the answer is sometimes that's true, but I don't think you should just immediately throw global variables out, because sometimes convenience trumps, perfect coding or something like that. Human beings, our natural way of doing things is we like convenient options, right? Sometimes there's a right way to do something that is not necessarily the most convenient way of doing things in real life. But many times the more convenient way gets the job done in the same, at the same level of quality as doing it in the less convenient way, right? So like, for instance, if I want to mow my yard and I text my neighbor and I say, hey, will you mow my yard? The yard still gets mowed, even though I stayed inside and played video games, right? It's convenience. Lawn still got mowed. All right, so in any case, we could have made that variable global, except we didn't know how to make global variables yet, so we didn't. But it wasn't a bad idea. So we had two options that we legitimately entertained. One option was to pass the scanner into our method as a parameter and say, hey, whenever you need to show the menu, here's the scanner to show the menu. Just take it, do your thing to read stuff in from the user, and then I'll get it back when you're done with it. All right, that was one option. The other option is what we ended up doing, which was defining the scanner as a local variable inside of our method, which effectively makes our method completely self-contained. Okay? But we had the side effect. The side effect is every single time we call show menu, we build a brand new scanner. So we run out to Home Depot and buy a new hammer every single time we need to hang a picture. All right? By human standards, that would be kind of ridiculous. But since we don't really care about our memory so much today because we have plenty of it, and we can rely on Java's automatic garbage collection. What is automatic garbage collection again?
Something about the pointer.
Okay. We had a really good answer last time from her. She even had the pointer count stuff, right? So something about the pointer. Okay, keep going with that. That's about it. What we got? We got birthdays. Oh, see, Vibe demo. It does this for other things. You would think that it recognizes I'm projecting and it would suppress notifications because it does that for other things. So it's not that that isn't even on their mind. But, you know, like, I think sometimes I'll get messages. Like, what if one of my friends doesn't realize I'm in class and sends a picture or something that probably shouldn't be of a neighbor who likes to send, you know, like, what do they call memes? Yeah, those that aren't always, there's a lot of profanity sometimes. So, I guess when that happens, it'll be funny. So, you know, we decided that since, the question was automatic garbage collection, right? She mentioned last time that automatic garbage collection was, I don't know if she actually used my phrase like the dump truck, but mentioned that every variable has a thing called a pointer counter, right? That's the number of things that point at that variable. And as long as that pointer counter is at least a 1, that means somebody has access to it. As soon as that pointer counter drops to 0, which means it's out of scope, nobody currently links to it, it's wasting memory at that point. Nobody can access it. So automatic garbage collection is a fictitious garbage truck that's kind of driving through Java's memory, Java's virtual memory, I guess in this case, and it's looking at each place in memory and saying, is the pointer counter a 0 here? If it is, let's go ahead and reclaim this memory and give it back. All right, so we can rely on Java when we use the new keyword here, which is our real estate agent, right? So this guy goes and gets us some memory. We can rely on Java's automatic garbage collection to reclaim that memory as soon as this method ends, because when this method ends, that means that any variables, like this variable right here, it lived and died, as he pointed out, with this method. So when this method ends, all pointer counters are reduced to 0 because that guy's now out of scope. And that scope is, in fact, dead. It came into existence for a period of time, and then it disappeared as soon as the method was done. When we call the method again, it doesn't come, the old scope doesn't come back. We get a brand new scope that looks pretty similar, and it looks identical to it, but it is a new scope. That make sense? All right, so we decided that for convenience, let's go ahead and self-contain this guy so we wouldn't have to remember what the nature of that parameter was. Like, oh, well, why do I have to pass this guy a scanner? The guy's just he's a machine you buy from Home Depot, you turn it on and it just works. It has all the stuff inside of it that it needs to work. You didn't have to add anything to it. Okay, so that's how we decided to write show menu instead of take a parameter in. Either one would have worked. We just had to make sure we had a scanner here that we could use to read stuff in from the user and ultimately return. Make sense? All right, so let's go up here and let's modularize some more of this. Now, notice here that these guys right here are using input for getting a player's jersey and this kind of stuff. So one thing we could do is, if we want to read in our initial roster, we can move that into a method as well, right? So I'm going to go ahead and copy this stuff. And we're going to call this guy static void get initial roster. I'll paste this stuff in there. I'll go ahead and steal that. And we'll stick with the same premise that will make our guy self-contained here. Okay. Now, notice it's giving us some errors. It's yelling at us that, hey, you're trying to put stuff inside of jersey numbers and player ratings, yet I don't have variables within my scope equal to those. Now, tell me, why would I not want to define those locally? Go ahead.
Because they're going to be accessed by the other methods and we want to keep them consistent.
Yeah, so, well, their scope needs to be larger than this. These guys this is our data, right? So our jersey numbers and our player ratings are things that need to be accessible really to all of our methods. This would be a great example of something to go ahead and make global. All right, but since we don't know how to do global variables yet, I'll show you today. What we are going to have to do, we're forced into passing those arrays in as parameters here. That makes sense? We need to provide that array to this guy so he can fill them. So we're going to go ahead and we're going to, I'm just going to come up here. And remember, I've indicated that you should probably type as many of these things as possible. So we'll take in jersey numbers there. We'll also take in player ratings. All right, so we'll take in those two parameters. Both are integer arrays, and now we have access to variables, name those in here. They didn't have to be called jersey numbers and player ratings here. Whatever I named them up here is how I would refer to them down here. That make sense? All right, so this code gets our initial roster. So now what we would do up top here, so what does this guy do? He defines our scanner for us to use. He goes through and he fills up however many elements are in jersey numbers, because jersey numbers and player ratings are parallel arrays, right? They're the same size, and bucket 0 of one of them is related to bucket 0 of the other one. All right, we're going to be moving away from this as we talk about our objects later on today. All right, so we'll be replacing this with instead of having two arrays, we'll have a single object that keeps both pieces of information, like a player object that keeps track of a player's jersey number and keeps track of a player's rating. All right, then maybe we'll have one array of players. All right, so get initial roster, we'll take in these two things. It goes ahead and reads in however many players we are trying to represent in our program. And he requires us to send him those two arrays that we want to fill. Okay, so let's go up. Now this guy, like we talked about last time, he has the word static in front of it, and we've decided right now that he has static in front of it just because I said so. We'll be moving away from that relatively soon as well, as soon as we get into objects. But static means that it's owned by the class. It's a class method. And class methods are called using the name of the class in which the method was defined. In this case, the name of our class is driver. So we would say driver dot get initial roster. Is that what I called it? Yeah, driver dot get initial roster. So what we'll do is we'll come up here and we're going to take this chunk of code out and we'll say driver dot get initial roster, and we'll pass it our two parameters. Now, this guy expected me to pass him an integer array followed by another integer array. He didn't necessarily expect me to pass him integer arrays named jersey numbers and player ratings. Those names have nothing to do with my parameter names down here. It's the parameter types that are important. This method requires two integer arrays. I can pass it whatever two integer arrays I want. He will name the first one jersey numbers and he will name the second one player ratings. He could have just as easily named them A and B. Okay? So I just happen to use the same name on both sides because it makes sense. All right? But they are different things. So I have two arrays I've defined up here, jersey numbers and player ratings. I want to get the initial roster, so I pass it those two arrays. Now notice this guy does not return a value. So get initial roster takes in these arrays, fills them, and then am I to expect that those arrays have stuff in them? I'll tell you that the code will work as I have it written. So now you tell me why. So that means the answer to this is yes. Are my arrays filled? So I define my two arrays here. So take about 20 seconds and look very closely at those two lines. Make sure you understand exactly what those two lines are doing. Jeopardy music. Go ahead. Initialized at 0? Yeah, that is a true statement. Yeah, I wouldn't rely on that, but it is true in Java. You'll have 5 elements and they'll all have zeros in them. All right. The thing I really want you to focus on here that is that those guys were built using the new keyword. What does the new keyword give us? What? Memory address. That's our real estate agent. It gives us a place in memory. So what value, if I were to print out jersey numbers or print out player ratings, what would print to the screen? Not jersey numbers at bucket 3 or jersey numbers at bucket 4. If I just printed out jersey numbers, that variable, what value does that variable hold? Holds a memory address. Okay? So when I pass jersey numbers and player ratings into this method, I'm passing a pointer into real memory where that array lives. That make sense? I'm giving it the actual memory address. I'm not giving it a copy of my array. Okay? I'm not saying, hey, here's an array with, hey, it's the same size, looks just like it, but it's a different array. No, I'm saying you can find my jersey numbers array here in memory. You can find my player ratings array here in memory. So when I'm down here, and this guy gets these two integer arrays, he's getting pointers to them. When I set jersey numbers at bucket I equal to the next thing that was inputted, I'm going to the real jersey numbers array that lives in memory up here. I'm going to bucket I of that guy and I'm putting a value there. Does that make sense? So I am writing to the actual place in memory. If we drew a picture of that real quick, because it's a very important concept. Let's see. Bet you I have some array pictures I can steal here. This will be good enough. Our guys, what, have 5 in them? What do I call this? Player ratings, something like that. All right, so player ratings is a variable that holds the value. The value it holds is a memory address, and we say that that memory address points to the place in memory where our array begins, the base address of that guy. Okay? Now, down here, I have my method. So static, what was it? Get initial roster, and this guy took in an int array, player ratings, blah, 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 and then did some stuff. Oh, kind of want the whole thing to be left justified. All right, when I pass in, and okay, so that's the method definition down here. When I call that method somewhere up in my program and I say driver dot get initial roster and I pass it player ratings, comma, dot, 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 whatever else I'm going to pass it. All right, so this is me calling the method. This is me defining the method. So this method is expecting an integer array, which is a pointer type. It's expecting me to pass it a memory address where it can find that array. All right, so when I pass player ratings in, I'm passing this value 200 in there, which means that this variable down here points to the exact same place in memory as my variable out here. They happen to be named the same thing, but I could have easily named this guy elephant if I wanted to. So now 2 separate variable names that both point to the same place in memory. So when inside of this method, if I start adding values to this guy, those values will be updated in the actual array in memory, not in some local copy of it. Does that make sense? Okay, so what we say there is that arrays, let's do variable passing. We have pass by value, and we have pass by address. Now, the reality is that everything is always passed by value because the value of some things is a memory address. Okay? But most books reference them as two separate names like this. So pass by address, these are things like arrays, objects, and we'll just throw an etc. in there. There are some other, actually arrays and objects, that pretty much is a catch-all. Arrays and objects, except we're going to say except strings, because even though strings are object types in Java, Java treats them more like primitives than it treats them like objects. All right, so pass by address, these are things like arrays and objects, means that a pointer to the actual value in memory is sent. So changes to that location in memory have side effect, which means that when you change that place in memory, everybody else who knows about that place in memory will experience those changes. It has side effect. Make sense? Pass by value, we can say primitive types. What are our primitive types again? Byte? Boolean? I think he said long, didn't he? Double? Float? Did you say short? All right, so we got all of them. So usually the easiest way to go through them is from the smallest, right? So byte, short, int, long, and then char is also an integer type. It's just unsigned, right? Okay. Then float, double, are two decimal types, and then Boolean. Make sense? That's probably the easiest way of working through them, rather than, but I think we hit most of them. All right. So now, if you were to give a definition of a primitive type, what would you say? What is a primitive type variable? We just listed what they are. Or we listed what they are. Now tell me what they are. What does it mean to be a primitive type variable? I'll throw a definition out that's not an acceptable definition, but it is an accurate definition. Any variable type that is not an object type would be a primitive type. Okay, so that one's not allowed. So if you were to kind of give a single sentence for what a primitive type is, what would you say? Okay, we're closer than your other answers today. Yeah, we'll go with that. So they only hold a value. So digits would really be numbers, right? So chars do hold numbers. Booleans, you know what? We're actually going to say that at the technical level, your answer is correct. Like way under the hood, because everything ultimately is a number. So that's right. But so my typical definition for primitive types would be something like variable types that are only capable of holding a value. That's it. Okay? We can throw integers in there. We can throw chars in there, whatever. They can only hold a value. They don't have extra magic tricks. So like this semester, we've already looked at strings, and strings know how to do a bunch of extra crap, right? Primitive types don't have that. So pass by value are our primitive types, and then also strings, because Java treats strings as a special case. All right, they treats them like primitive types, even though they are in fact an object type, evidenced by the fact that they can do more than just hold a value. Okay, and these guys, when they're passed, a copy of the value contained within the variable is passed to a method, and changes to that copy do not have side effect. So if you change the value of a copy, the original guy does not get impacted. No side effect. Make sense? Okay. And ultimately, from our perspective here, this comes down to, with the exception of strings. So put a little note in your head that strings are special cases. Okay, everything other than strings, If the new keyword is involved, it's passed by address. If the new keyword is not involved, it's passed by value. Make sense? So, new keywords involved, we will have side effect. Be careful where you tread. You start making changes to it, which is sometimes what we want. In fact, in our case right now, that's what we want. We'd like to be able to just make our changes and not have to return crap or anything like that. Just say, oh, we'll go ahead and throw your roster in memory. No harm, no foul. That's what we want in this case. But we want to make sure that what we're trying to do is what we're actually accomplishing and that you're not working with a copy of stuff. Okay? New keywords involved, expect side effect. New keywords not involved, don't expect side effect. You're working with a copy. Okay? Except for strings. And in actuality, strings actually get more complex than that because you can, we'll talk about this with objects, you can create a string using the new keyword. So I can create a string like this. You know, we're used to saying something like string s is equal to hello. I can also say string s is equal to new string hello. Those almost do the identical thing. We'll talk more about that at some point, but in this conversation, they do the identical thing. All right, but both of these guys would be passed by value because they're strings, even though the new keyword is involved here. Okay? I usually refer to this as syntactic sugar. It's a shorthand for something like this. But it actually is a little bit more complicated than that. This gives us, here, I'll just talk about it real quick. It only takes 30 seconds. In these two lines, S and S2 both have the identical memory address. Because when hello was first created as a string literal, since it did not already exist in memory, presumably in our program, it is created once. When we use that same string literal again, it sees that, oh, that guy's already been created. Rather than have a second string literal that says hello, let's just let this guy know about the one that already exists. So S and S2 here, if we were able to look at the memory address, which Java does not allow us to do that with. We can't look at the memory address of S and S2, but S equal S2 would return true in that case. We don't compare strings this way. We compare strings by saying S dot equals S2. That's how we actually compare strings in Java. Because when we're comparing strings, we're actually interested in the contents of the string. Is the word hello the same as the word hello? The dot equals here compares hello to hello. This guy, did I just randomly write that in a different place? I did. Problem solved. So the dot equals compares hello to hello here. This guy here compares address of S to address of S2. You could replace address with value of S and value of S2. We immediately resolve the value of S to be hello. And we resolve the value of S2 to be hello. But their actual value is a memory address. So when I use the equivalence operator here, this is the primitive equivalence operator, I'm comparing the memory address S to the memory address S2. Even though we can't see what those memory addresses are, because Java kind of hides it from us because it treats them as primitive types, it is a memory address. This guy would return true. All right, and so this is true. This is true. Now, we use these exact same lines. We paste that there. Is the text still big enough to read? All right. Now when I say S equal S2, this will be false, because I used the new keyword to create these, which specifically requested a new place in memory for that string. So these guys will have different memory addresses in them. But S dot equals S2 will still be true. That's comparing the contents of the string. That makes sense? All right. Pretty important concept, because a mistake that beginning programmers often make, and part of it is just because it's an easy mistake to make, but another part of it is even if you are an experienced programmer and you're coming from a different language, several other languages make the double equal sign when comparing strings, look at the contents of the string as opposed to the memory address. They artificially make that work the way we would expect it to work. Java does not. Okay. Java treats the double equal sign as the primitive equivalence operator 100% of the time. It's comparing the actual value that lives in the variable, not the value at the memory address where the variable points. Make sense? So when we want to compare two things, if we're comparing two integers, we use double equal sign. We're comparing two chars, we use double equal sign. It's an easy next step to say, oh, I want to compare the contents of two strings. I'm going to use the double equal sign. Easy enough mistake to make, right? In fact, in many languages, it's not a mistake. If we do that in Java, the risk is sometimes you will get an accurate answer. So for example, if I'm up here and I say S equal hello, that'll work. But it works for the wrong reason. Hello is a string literal, which will boil down to its memory address, which is the same memory address that happens to be stored at S, because it has the memory address of the string literal hello. So this guy will boil down to true, but which could give us this false sense of confidence that we know what we're doing. But it boils down to true for the wrong reason. This is saying that both of those guys have the same memory address. As opposed to down here, if I take that exact same line and I say S equals hello, that would be false. Because S up here, down here was built using the new keyword, which is in a different place in memory than the hello literal that we presume was created. But this is a literal value. Therefore, Java is going to look up that guy in literal memory space. So Java has this nice little side room. If you want to think about a little, they've set aside some memory for holding literal variables. So like the digit zeros in there, 1 and 2, things that don't change. And then we have ones we could add to that, like words, strings. All right, so that's where it's hunting for those literal things. That makes some sense? So if you never want to run into problems, never compare strings using the double equal sign unless you want to compare the memory addresses. If there's a problem you're solving that you specifically are interested in, are they the same memory address, then you use the double equal sign. Under every other circumstance, use dot equals, because it will give you the correct answer for the correct reason. Even though double equal sign will sometimes give you the right answer, but for the wrong reason. Okay? This is really a, let me kill all that. Strings, etc. Good enough. All right. That might make a good quiz sometime. Something along the lines of that. All right, so we have this idea of pass by value versus pass by address. We have a good understanding of that. Also would make a good quiz sometime. Okay, these are important kind of go-to moves in programming. All right, so because of this, these two guys are passed by address, which means that when we make changes to them in here, we're changing the actual memory location. It has side effect. All right. Therefore, after we call that line up here, where are we at? Our rosters are filled. Well, at least as well as they were filled before. Okay? Okay, so now this is our show menu. So we've created a variable named option. We're going to set option equal to whatever show menu returns, and show menu shows our menu and reads the user's input. Then we're going to start responding to the stuff from there. So what I'm going to do is I'm going to take all of our code from U. Okay, and this is update player, right? We're going to come down here. We'll say static void update roster. Paste that code in there. Again, this guy needs a scanner, so I'll internally define our scanner, keep it self-contained. It also needs access to our jersey numbers and our player ratings, so we're going to take those two guys in as parameters. All right, so that is our code for updating a roster. Come back up here. What do we do in this case? We call driver.update roster, passing it our two variables. All right, and then what does A stand for? It's the above, right? So display all guys above minimum rating. So we'll come down here. We have static void display above min rating. Throw the code in there. This guy needs it needs an input. And then it needs our jersey and player ratings. Okay. Come back up here. Replace all this stuff. Driver.display above minimum rating. Give it those two things. This guy is replace player, right? Static void replace player in roster. Paste that in there. We're going to need our scanner again. Now the fact that all of these need scanners probably indicates we should have made scanner a global variable, just let everybody have access to it, but this isn't hurting anybody. And then we're going to need the jersey number and the player ratings. Come up here. Get rid of all this stuff. Driver dot replace player in roster. All right, and this is just show roster, right? Static void show roster. And we do not need a scanner for this guy. So we're just dumping the contents of a roster, but we will need our jersey numbers and player ratings. Driver dot show roster. Take a couple of these extra spaces out. Hopefully it'll all squeeze onto one screen. Close enough. Say it's close enough. That's main now. Get our initial roster. Show the menu, read in an option. The option was U, update the roster. The option was A, display above minimum rating. The option was R, replace player and roster. The option was O, show the roster. Reads like an algorithm, right? Now, scroll down a little bit, we see there's a whole bunch of logic inside all those guys. Okay, all that stuff is there. But if we want to make ourselves feel better, we can do the little minimize thing here. So there's all my functions down there that has scary stuff inside of them that we've written and tested and don't have to worry about. And now we just call them from up here. Make sense? All right, so now let's say that we wanted to make that scanner variable global. Would have saved us a little bit of work since we were using it so often, right? So I'm going to go ahead and let's just go down to, I'm going to expand each of these guys because we're going to need to change a little something in here. All right, so we have this scanner called input here. And I happen to use that scanner input in replace player and roster, in display above minimum rating, in update roster, in get initial roster, and I should have used it inside of show menu. I just happened to use a variable called elephant in here. So here we'll just change that to input. We'll change this to input. Now we use the same variable name in all of them, right? Okay, so what I'm going to do is, since we are using this guy so often across multiple scopes, it would not be a poor idea to make it a global variable. Especially a variable like this, which is really a tool that we need to have access to in multiple places. This is less about storing data and more about just giving us the ability to read stuff in from the user. So I would go all the way up to the top, inside of the opening curly brace for our class, but outside of our main method. Okay, this is our global scope as far as we know right now. Once we start throwing other objects in, which are in separate Java files, things get a little bit more complex. But for right now, our global scope lives here. This is as global as we can get. So I'll go ahead and define my scanner input here. But I want this variable to be owned by the class. So I'm going to put the word static in front of it. Okay. Otherwise, if I had not put static in front of it, I would not have been able to use it, because it would have been an instance variable. Therefore, it could only be accessed from an instance context, which we don't know what that is yet. All right? We only know about static context because all of our methods have static in front of them. So a method has static in front of it, it's inside of you're operating from a static context. Therefore, you can only access other variables that are available in static contexts. And for right now, what does that mean to us? It means make everything static, and life will be good. Okay? So I've defined a variable inside the global scope, named input of type scanner, and I've made that guy static, which means that it is accessible within every single static context within the global scope. So now that I have that guy, I can come down here. I can get rid of that line. I can come down here. I can get rid of that line. Come down here. I can get rid of that guy. I can get rid of that guy. I can get rid of that guy. And it'll still work because I've exposed that variable at the global level. And really, it's more efficient now because I'm not creating a brand new hammer every single time I want to show the menu. I bought the hammer once, and I go and grab it whenever I need it. Make sense? So from a human idea, a human perspective of, I guess, fairness or logic or what makes sense, this is better. But most programming books would probably say this is poor programming practice because you've made a global variable. I mean, I don't care if you avoid global variables like the plague. It will make your life harder in some cases. Now, having said that, let me immediately confuse you by saying I'm a big fan of self-contained methods. Because as projects get larger and larger and larger, let me show you a quick example. So this is one of the projects I'm working on with one of my clients. So this is an iPhone app called Squad. It's like an app for managing like intramural sports, baseball, football, that kind of stuff, for rosters and doing roll calls and stats and all this stuff. Okay, did I get all of them there? Yeah. Every one of these files that looks like it has a little flame next to it here, every one of those in our world is a .java file. These are .swift files, a different language, but similar enough. All right. Do you think that it would be a great idea to have functions I wrote in these reliant on things from some of these other files? Or as we start getting hundreds and hundreds and hundreds of thousands of lines of code, having more things self-contained might make a lot of sense, right? Because I don't care how great your memory is, you're going to eventually start forgetting what belongs where, right? You know, and then to give you the catch-all, when things make sense to be global, we have this thing up here called Squad Core, which is a singleton, which we'll talk about. Come on. This is a very big application. So things go a little slow on this guy. Let's get Squad Core up. There we go. This is my global catch-all. When I need functions that are available throughout the entire application, okay, this is the new global scope. When you have multiple .java files, you're going to need to have a governing guy that gives you global access across all of them. So inside here, I have a whole bunch of variables, a whole bunch of functions, all sorts of stuff that does different things. You know, get stat collections, update scores, things that we need to do from various screens in the application. Okay? Global variables are not always bad. Global functions are not always bad, but there is a right time and right place for things. So I'm a big fan of things that can be self-contained to stay self-contained. I'm also a big fan of not repeating code logic more than, let's say, twice. More than once is probably a good rule of thumb, but sometimes to give you the self-contained aspect, if you only need to do something twice, maybe you just go ahead and let it stay self-contained so you just don't have this extraneous function living up here global that you only ever call twice. All right? But I'm a big fan of self-contained when it makes sense. But if you do need to make something accessible to a lot of different places, global makes sense. Okay? It's not taboo. Okay? Just approach it with a logical decision. Does this need to be global, or can it be self-contained and will life go on? Does that make sense? As your projects get larger and larger and larger, having more things self-contained is going to make them easier to maintain because you won't be trying to fix some code inside of this method and realize that it's reliant on code that's strewn all about your application. All right? Okay. So we made that guy global. Now, we could have also made our jersey number and player ratings global. You know, that in this particular case, if we're going down that logical path, would that have made sense? Do all of our methods need access to those? Now, it's good we wrote them the way we wrote them for right now, because it allowed us to talk about that concept of pass by value versus pass by address, right? And understand that pointer stuff. But in this case, could we save ourselves a little complexity by saying, you know what, pretty much everywhere in this application needs access to those. So rather than just passing the pointers around, which really isn't a problem, right? I mean, passing a pointer is just, it's the size of it's 32 bits in a 32-bit operating system. So it's not a huge memory address. So even if you have a 1,000-bucket array, the address to that array is 32 bits. Same as a 5-bucket array. It's 32 bits. Its base address is going to be somewhere in memory, and that's what the address of it is that base address. Make sense? So passing the address of an array is not an expensive thing, but it is kind of a tedious thing, right? You know, we passed in the same crap to every single one of these functions. So we could have made our life a little easier, again, after thinking through the problem, not just randomly saying, oh, let's just make everything global. That's what we want to avoid. Don't just make everything global and say, oh, well, I'll always have access to this. Convenient. All right. We'll move these guys up here. We'll make them both static because we're supposed to right now. Which then will allow me to not have to pass those guys in as parameters to any of my methods. And notice these are all getting underlines under them because I haven't these are me calling the methods. I have to go and update the method definition to not expect those parameters, right? So I take those parameters out of there. And then these guys no longer need to have access to those. Okay. Now, the one thing I'd say here, so let's just look at show roster as a quick example. This will work as is. I personally don't like the way the syntax is written. Because this is a static context, we have direct access to the variables that are in the global static context. There is an invisible driver dot right there. This guy is presumed to be there when we don't put it there. Now, just because it's not required does not mean you should not put it there. So we talk about that for a minute. What's the difference between this line, me saying driver.jersey number, and just saying jersey number, or jersey numbers, from a performance perspective? Do you think one of these is faster than another? If I'm asking the question, probably. We'll start off. The answer is yes. One of these is faster than the other. In fact, I'll even tell you which one. This is faster than this. Why do you think that is? Any guesses? I'll give you a hint. Deals with variable resolution. When we resolve a variable, every variable resolves to its most local scope. Right? Every variable resolves to its most local scope. What's the most local scope of this guy? Well, it's going to check in the most local scope, so it's going to check in the scope associated with show roster. Then it's going to check in the next most local scope, which in this case happens to be the global scope. So it's going to have to check in two places. This guy I've given it the full path of where to find it. Don't look locally. I'm talking about the global guy. So if you're at home and you're looking for some Scotch tape, and there's 10 places you could look for Scotch tape, and I say, oh, it's in the drawer upstairs, you can not look in those 9 places and immediately go to that drawer upstairs to grab the Scotch tape. Now, if I just said, get some Scotch tape, would you eventually have found the Scotch tape? Yeah, eventually, after checking potentially 10 places, right? You would have eventually found the Scotch tape. In the end, we have Scotch tape, either way. But one of the ways was faster than the other. Make sense? Now, having said that, the following question would be, do we care? As programmers, should we care? From an understanding perspective, the answer is yes. I go a lot deeper into this stuff than most books and other programming classes maybe do, because it is important stuff to understand. From an understanding perspective, we should care. In this particular problem, this is the problem we're solving right here, we shouldn't care. Makes no difference, because computers are fast. And even though I'm telling you at the microsecond level, at the number of CPU cycle level, this is going to be faster than this, do you think a human being is going to perceive that speed improvement? Not even close. They're both good. Eclipse, the sluggishness of Eclipse will, pun intended, eclipse any speed gain that we're going to get from this. Okay? So, for us, either one of these is fine. The main reason that I say to use driver dot is so that this works. Driver dot Jersey numbers, and I can just press enter and never misspell it. That's the biggest reason for us to use this programmers, to minimize the number of typos. Because right now, that's one of your big enemies, right? You know, little stupid things like forgetting to put an S on the end of it, or that kind of stuff. And then you're like, well, where's my error coming from? And as beginning programmers, your natural approach is to just start randomly changing stuff, which just makes it worse. It's like throwing gasoline on the fire, right? Okay? So I might throw that other statement in there, is never make a change without first contemplating why you're making the change. So there should, sometimes your changes will be guesses, but they should always be educated guesses, not random throws in the dark. It's like, well, I'll just delete that line. Maybe that will help. And if that's your approach, that maybe that will help, and there really is no logic behind that other than just desperation, probably shouldn't be doing it. Get used to thinking through it. All right. So punchline here. I don't care which of these two you use. I don't care if you specifically spell it out inside of the static context, or you rely on your knowledge that this will access the right variable. Both of those are fine as long as you understand why this works. Not that it just magically works. Okay, that ultimately Jersey numbers right here, this variable, will resolve to its value. And the first place it looks will be in its local scope, and it doesn't find a variable defined in there called Jersey numbers. Then it goes up to its more global scope. All of these methods live inside of the global scope. So the next scope up for that guy is this guy right here. And it finds Jersey numbers in there. So it'll actually be in the second place it looks. Make sense? Okay. So we pretty much compressed. We gotten our program down to a pretty small footprint now. Main looks manageable. If we just glance at main here, it makes sense what it's doing. Okay. And that allows us to go and quickly find where, oh, update roster isn't working. Where's the logic for that? Well, it's going to be inside of our update roster method. So we can go and directly get to where the problem likely is. Okay, so let's start our discussion about objects. So object types. Like we already spoke about today, we've already been introduced to one object type, and that's strings, right? But we really want to treat those as primitives, treat them as special cases. All right, so an object type is a variable type that can hold 0 or more values and potentially do more. All right, so for example, a string holds a collection of chars, probably as a character array, a char array. And then it has a whole bunch of methods that work on that, that manipulate that char array. Okay? So that's what an object type is. Some are built into the language. We really could say many are built into the language. And if we go and look at the Java documentation here, so right now I'm literally showing all classes. I'm not just inside of java.lang. So here's all the various Java packages that are available in the Java programming languages, Java programming language. The only one we use by default is java.lang, and then we've also used java.util to give us the scanner. All right. These are all the classes, all the objects that the Java the Java metropolitan language, like Milwaukee metro area, right? That the Java metropolitan language has given us to do stuff with. Lots of classes, right? All right. I have been writing Java code since the day Java came out, which was, I don't know, 94 or 5 or something, a while. I would be surprised if I've ever seen, well, I've probably seen them because I just scrolled through a bunch of them, but if I've ever used anywhere near 10% of those. It's probably more like 3% or something like that. You know, for most problems, general purpose problems, you're going to use this cluster of objects, right? So typically you're spending most of your programming life inside of java.lang, java.util, maybe java.io. Maybe those are your 3 that you spend a majority of your time in. Now, if you're writing some sort of security software or something like that, maybe you'll live in java.crypto or something like that, which has some cryptography stuff in it. But you really only go to these other things when you need it. I've done some stuff with the XML stuff when you're parsing XML documents. But in general, a majority of these classes were invented for special purpose things, but it's not really what we need. So we have a bunch of objects that are built into the language that are available to us, but then we also have the ability to create our own objects when we need something that can store something that isn't already in existence. You know, Sun Microsystems, now Oracle, could not have come up with all of the things we might ever want to create. We create our own organizational tools. In this soccer application, we created 2 arrays that we're using as parallel arrays to hold information, hold data about players on a soccer team, right? It is soccer, isn't it? I think so, yeah. So, for example, we could choose to create a player object, our own player object. And that player object might have a jersey number. That is an int. And it might have a player rating. That's also an int. It might keep track of those 2 pieces of information for us. So rather than having 2 arrays where one array holds a bunch of jersey numbers, the other array holds the equivalent number of player ratings, and those guys are related to each other, I can have a single array of player objects. And each of those individual player objects holds 2 pieces of information about the player. Make sense? This would be an object-oriented approach to our soccer problem. So we'll start writing this in preparation for next class. So I'm going to come into our, where's our third one from the top? This guy? Okay. I'm going to go ahead and I'm going to right click here. I'm going to say new class. I'm going to add another Java file to my project. All right, we're going to call this guy player. We'll go ahead and hit finish. And we're going to say that a player keeps track of an int jersey number and an int, really it's just int rating, right? Good enough. So every player will have these two pieces of information. We'll have those two pieces of information. Now, to create a player, well, since we're down to our final minute, let me just kind of give you the quick version of this. I'll do it right up here at the top of main. I can say player P is equal to new player. So now we've created a new player object, and then I can say player dot jersey number is equal to 5, and then P dot, not player dot, it's P dot, and this guy would be, what do I call it, rating? Rating is equal to 12, something like that. So I've created a player, and I've set its two fields to something. Now notice that I access these guys using P dot instead of player dot. And notice that these guys do not have static in front of them. All right, so we'll start off with that discussion. Next class, talking about instance methods, instance contexts. Homework assignment is to do exercise, whatever it was. Did I close the thing? Exercise 6.16 from the from chapter 6. 6.15 will be a warm-up. You can do it if you want, but it's really kind of almost just the first piece of 6.16. All right, I'll see everybody on Tuesday. Don't forget about the Vibe thing down in the caf. Go and check it out.